define first what is T flip-flop. The T stands for toggle. This flip-flop acts like a toggle switch. The output will change with respect to the input along with the clock signal. So it means that the output will toggle with respect to the input along with the clock. Here is the logic diagram of a T flip-flop using NAND gates. And on the right side is the symbol of the T flip-flop with an input T and a clock with an output of Q and Q prime. Since the basic circuit of a toggle flip-flop is identical to a JK flip-flop, where we shorted J and K terminal, resulting into T flip-flop. Now let us fill in each of our tables. This will show how the output responds to different combination of the T flip-flop and the clock inputs. Here, we will take the first state. When clock is 0, the flip-flop will not operate and the state will be stored. So whatever the value of T, the output will be in memory mode. When clock is 1, there are two possibilities of T. T can be 0 or it can be 1. Now if T is 0 at the time, QQ prime will be in memory mode. And if T is 1, QQ prime will go in memory prime mode or a toggle. Next is the T flip-flop in the form of next state. When clock is 0, the T is in don't care. Qn plus 1 will stay in memory or in previous state. Now when clock is 1 and T is 0, Qn plus 1 stays in memory or in previous state. And lastly, when clock is 1 and T is 1, Qn plus 1 will go on memory prime or in toggling. Next is the characteristic table that will define the next state of the T flip-flop in terms of T flip-flop inputs and the current state. So we have Qn and T inputs with 4 possible combinations. These are 0, 0, 0, 1, 1, 0, and 1, 1. So when T is 0, here in memory, it means that whatever present state that you are having it will be in the next state. The present state Qn is 0, thus Qn plus 1 will be 0. Now when T is 1, we will have a toggle state. Whenever the value of our present state, it will be going to be complemented as the output. Qn plus 1 will be the complement of Qn, which is 0, thus it will be 1. When T is 0, Qn is in memory and Qn plus 1 will be 1. And if T is 1, it will toggle and Qn plus 1 will be the complement of the present state Qn. Here Qn is 1, so the complement of 1 is 0. So based on the characteristic table, we can directly see that Qn plus 1 is equal to Qn XOR T. Next, let us fill in our excitation table. This can have possibilities of 4, which are 0, 0, 0, 1, 1, 0, and 1, 1. To have our T, we need to tag this table at the left. So if it is 0, 0, T is 0. If it is 0, 1, T is 1. And if it is 1, 0, T is 1. And lastly, if 1 and 1, T is 0. So from this table, we can say T is equal to Qn XOR Qn plus 1. So simulating a logic circuit of our T flip-flop. If both the preset and clear are on, the Q and Q prime are blinking. It means that the flip-flop is free to respond to the toggle and to the clock. So now if clear is on and preset is off, the Q was set to 1. So the clock cannot operate itself if preset is set to 0. So the next one is when preset is only on, the Q prime is on and the clock has no effect if clear is set to 0. So this is the end of our video tutorial. Have a good day.